All right. Welcome, everybody. Thanks for joining once again. This is our Inner Systems Programming Contest winners webinar for May 2024. We're very excited about this session. All of our programming contests are fun, and we celebrate the work of the winners. This one is particularly cool because it's showcasing not only the great work of all of those people that participated, but it's also showing off some of the very latest inner systems technology in generative AI and ML. We had an amazing number of submissions, 16, I believe, submissions this time, something really to celebrate. We love all of the engagement with our contests, and we're excited to go through some demos for the winners. This is the winners page that's on the InterSystems developer community. You can dive into the details yourselves. As always, there were two categories. There were the experts nominations, and we have winners from 5th place to 1st place. And we also have a list of people who got tech bonuses as well, as you can see here. And then there were community nominations, 5th through 1st place, as we usually do. Again, you can follow these links and dive into all of these details yourselves. There's a lot of overlap, as there often is, between the community nominations and the expert nominations. In this session, we will be having demos for 5th place through 1st place in the expert category. I believe that the 2nd place team is not live with us on this call, so I think we have a video demo for that. But before we kick off the demos, I just wanted to stop and ask Tom Dyer, who I believe is on the call and is leading our AI efforts here at InterSystems from product management, and just wanted to see if he had any kind of overall thoughts on the contest.
Yeah, thanks, Dean. Absolutely. So it was great to see all these submissions, and it was actually a bit overwhelming to actually get through and look at them. So we do apologize if anyone felt slighted and not recognized for their their great work. There was so much there to look at, so it was really a good problem to have, I guess. But I also wanted to note that, even though we're just providing some kind of key foundational aspect for AI applications, having vectors able to be stored and searched within InterSystems Iris, what you really saw in these submissions was kind of reaching out beyond that and using our interoperability to do orchestration, which I think is a big area for us to look at and see how we can improve those parts of the products to really kind of support the whole application development process for these types of applications. So I thought that was very interesting and really good to see, and gives us a lot of work to do, because there's definitely improvements that could be made there. So we really like all the feedback that you can give us for what we can improve in using these tools in this new kind of development area within AI. It's a huge area, and it's going to be even bigger as time goes on. So thanks very much for taking this journey with us.
Awesome. Thank you, Tom. Appreciate it. So before we dive into the demos, I just wanted to mention that we were very excited to have some people join this programming contest when they found out about it from one of our hackathons that InterSystems sponsors and participates. I believe it was Hack UPC in Spain. So they joined this, very excited. Thank you for participating. And we also had one of the startups from our Inner Systems startup incubator, Celestinos, join this programming contest. Thank you very much. We appreciate that. And for anyone watching this video, if this is the first time you're kind of hearing or learning about Inner Systems technology, we absolutely invite you to join our developer community, to join in these programming contests. You are all welcome. All right, so let's get started. Is the fifth place team Companies Search app? Are they here to demo?
Yes, I'm here. Can you hear me?
Great. I can. Thank you very much, Julio. And in just a second, you can introduce yourself and step through the demo. I do want to give you and the other teams just a warning about timing. We will have to hold you to 5 minutes, and unfortunately, we'll have to cut you off if you go over because we have several demos and we are limited on time. But after that, just take it away. Thank you very much.
Okay, thank you. So I'm Julio. I'm from Brazil. I work at Shift, a company that uses InterSystems Iris, Cache, and Ensemble in our day-to-day business. We do laboratory information systems for here in Brazil for big companies. And I and two other colleagues from Shift joined the context to share our experiences with InterSystem, Iris, and it's a very interesting subject. So I'm very glad to participate of this context and even happier of winning the 50th place. Our project is company search. We did use vector search to summarize Glassdoor reviews, pros and cons, just to help. And we made an API for people to search for terms. And then people can use this API to look for collaboration with other companies, to look for job opportunities, or to avoid some companies they don't want by searching terms. So we use these terms to select the companies using vector search. So we transformed the terms on the Glassdoor with the vector search. And then after we retrieve the companies, we summarize all the opinions using ChatGPT for Iris. So we can get a good summary of that, so we can read about these companies that we selected. So I'm going to the demo. Can I share the screen very fast? I think it's this one. And let me look at here's the explanation. You can find it on the GitHub, but let's go to the demo. So this is an API. After you load and run the containers, you can search for terms here to retrieve information from companies on the Glassdoor. Our database is from Kaggle, okay? So I'm going to search for innovative companies. So it takes a while, not because of vector search, but because of ChatGPT summarizing all the opinions lived on the database. So here's the, let me take this out of the way. So it's searched from innovative, and by standard, we retrieve 3 companies, which overall rating. So here's the first 3 one that we found. and they share this summary highlighting the good aspects of the company. We can also search for, just pasted the results here. It's easier here, and look for cons. If I use the parameter pros equals 0, so I'll search for the cons. I'll reduce the number of results to reduce the time. I'll search for companies, and then they will look for this for companies which flexible hours is not on it's on cons list.
Julio, sorry, we're running out of time with your demo,
Okay.
but this is really great. I think we probably should use your company search tool to find startups for our InterSystems Venture Fund, which are the most innovative. Thank you.
Okay.
Yeah, thanks a lot.
Thank you, Julio. Great work. Are there any questions for Julio and the team before we move on? All right. Excellent. Let's go to 4th place in the Iris Health Coach app. Do we have that team?
Hello.
Hello, Zach. Thanks
Hi.
very much for participating. Take it away, introduce yourself, and 5 minutes of demo. Thank you.
Sure, thank you. Hi, I'm Zach. I'm based in Singapore, and I'm the founder of a startup called Marymount Labs that is also part of the InterSystems Celestinians Incubator. So one of our goals for being in the InterSystems Incubator is, of course, to learn how to use InterSystems technology and to integrate it into our software solutions. So I found this hackathon to be an interesting opportunity to learn how to use vector search. And I found that to be particularly useful for the suite of patient engagement solutions that my startup is building for primary care clinics in Singapore. So one of the biggest problems that GP doctors in primary care clinics have is really how to increase the level of awareness and increase the uptake of preventive health services like vaccinations and cancer screening among patients. And all of these treatments are already available. So let me just share my screen to make it clearer. So my team decided to build a chat bot that is not just a bot that delivers facts about these preventive health services, but rather a bot that can persuade people to actually take up these preventive health services. So the key insight here is how could we make this chatbot more persuasive? So what we did is to really design a chat agent instead. And this chat agent is based on a health belief model that is found in social theory. So health belief model states that whether a patient decides to take a health action like go for a vaccination depends on 3 factors: their perceived vulnerability to that disease, what is their incentives for taking that action, and what are the barriers to taking that action. So we use this framework to design the chat agent. And here's the architecture for our application. So for this chat agent, when someone engages with the agent, this user input would be passed into a business service. Here we're using the InterSystems production framework as the backbone for our entire application. And we have a business process that essentially does some prompt engineering for whatever input that the patient provides to this chatbot. And we query the Iris vector store to find the most relevant chunk of information related to that preventive health service to the patient's query. At the same time, we have 2 components to our chatbot agents. So the first component we have is a scoring agent. So the scoring agent would in real time look at the user's inputs and assess the level of incentive, vulnerabilities, and barriers based on the health belief model of that patient. And these scores would be passed into the second component of this agent, which is the conversation agents. So the conversation agent will both have context that is retrieved from the iris vector store, as well as the scores based on the health belief model. And this information would allow the conversation agent to know how to drive it to persuade the patient to its best abilities. So here's a demo of how it works. So the user here is just asking some questions. And each response provided a chatbot considers the level of incentives and vulnerabilities at each stage.
Zach, apologies, but we are running out of time. I believe everyone can walk through your video because it's available on Open Exchange, right? And
Yes, it's all available
thank you.
on
This
Open
is
Exchange.
amazing. Colleagues, any questions to Zach?
I had a question, Zach. So what I saw is you have two agents, and I wondered if you tried to do it in just one agent, and what why you decided to split it up into two agents. Was it?
Zach, if you're talking, you're on mute.
You're on mute, Zach.
Yeah, sorry, there was a Zoom disabled. But yes, the reason for breaking this up is really, I think firstly, there's token limitations with each agents. So by having these two agents maintain separate contexts, they better function in parallel. At the same time, the scoring agent is able to work in parallel with the other agent retrieving information from the vector database. So in summary, lower latency and better context management.
Awesome. Yeah, really cool app. I like it so much. So good job. Thank you.
Hey, Zach. Great presentation. Nice to see a fellow Singaporean out here. Anyway, I was curious to know about how you're using the scores to influence the response. Are the scores like numbers, and then like how does that affect the response?
So for now, the scores are just a binary scale, 0 and 1, 0, and -1, 0 if there's not enough information. So those scores will just be fed in as additional context to the conversation agents. I think after this hackathon, there's another thing I want to experiment, which is using log props to identify the confidence associated with the response. And I think this would probably give a more granular look at how the health belief scores can drive the conversation agents.
That's pretty interesting. I like how you're using both like structured and unstructured information. And it would be pretty cool to see how the patient's belief system changes over time. You know, you could track this, have a graph, pretty interesting stuff. Very nice.
Our application includes a graphing feature to track the scores over time as well.
That's awesome. Thank you, Zach. And I was very glad to hear about your journey, because it was the journey was just as we in InterSystems hoped it could be, that you're part of our startup incubator. You're kind of learning our technology in that forum, but then also you were able to explore our programming contest to kind of check out a very new aspect of our technology, the iris vector search. And so it's fantastic that you were able to see those opportunities and take advantage of them. That's just how we hoped it would be. So that's fantastic. Let's jump to the third place team, Iris AI Studio app. Is that team here?
Yeah. So Ikram, I have joined here. So let me share my screen.
Thank you.
So I hope my screen is visible. So to give a quick overview, so what Iris AI Studio tries to achieve is give a playground or a simple, a no-code or low-code kind of tool for non-technical stakeholders, like say program managers or some other people who are trying to explore the technology but not having that right kind of know-how on how to code. So they could come here and then they could load data from different sources. Say they have it in their Airtable or say they have it in their local storage or something, they can easily load it. And while loading, they can give the configurations, like the embedding configurations they can give on which particular embedding model to use. And the data would be loaded into the Iris DB as embeddings. So this complete flow is called connector. And then once the data is there in the Iris DB as embeddings, that can be retrieved through different methodologies, like say query, chat, or if they wanted to build a recommendation engine on top of that, or if they wanted to build a similarity search on top of the data, they can do it like in a much easier way. So the playground gives an option to chat with the data or get a recommendation from the data. So the code is there in the GitHub, and I could quickly walk through the video and show. So the user comes in and selects a file for which file to upload, and here they could see what is a configuration for embeddings, and we use Llama index to do the loading of files, and then use the Llama iris library, which internally calls SQL query to load this information into the Iris DB as vector embeddings. So here, yeah, so this is how the data would look like. It will have text, node ID, and also it will have the embeddings here. So any reference when we're doing it, will call back, show back the node ID so that we could go and refer the data. In the retrieval way, say semantic search is where you could just do a query on top of the data. You could give a query and you could get a response, simply like running a chat PDF or like chat with your docs or search with your docs, right? Something of that sort. Chat is almost the same thing, but it also has the context window on knowing like what happened before. And when it comes to recommender, it gives an answer and also tells like where it tried to source that answer, and gives we can give a count on how many similar things we wanted. It will give that. Similarity is also pretty much same, but it focuses on what is the score cutoff and how many results we wanted to get out of. So pretty much this is a thing, and there are quite few configurations which you can use in settings. Open for questions. Thank you.
Thank you, Ikram. Any questions to Ikram?
Very nice. Thank you very much. I wondered if for another possible either use case or feature would be to plot the data and show how the different embeddings compare to each other. Because
Yeah.
one of the things about choosing different embeddings is choosing one that's good for your data, that separates things. And so in addition to just doing the query, it might be nice to visualize that with the kind of, these clustering embeddings or clustering algorithms.
Yeah, that's a really valid input. Like, I think that's the goal of Playground, right? Like we try to give different configurations and try to see how the results vary. I think, yeah, that would be the next step on how it goes.
Very cool.
Excellent. Thank you, Ikram. Appreciate it. All right. For the second place team, I believe is the team here, or are we going to show a demo?
Yeah, team reached us out and apologized that they cannot join us, but they created a video which is within our time limit. So if you don't mind, so I can share my screen and run it through.
Wonderful. This is Iris Medicopilot app.
Yes, and here is the
Often
video.
relies heavily on the experience of admitting physicians, which can cause delays in patient care, especially when inexperienced residents handle non-critical symptoms. This situation can also lead to unnecessary hospital admissions, straining resources, and increasing healthcare costs. Our focus is on improving care for pregnant women. Through a survey with friends working in a major hospital in São Paulo, Brazil, we identified a significant issue. Inexperienced doctors often admit patients with non-risky symptoms, occupying beds that could be used for those with more severe conditions. This misallocation of resources highlights the need for a more efficient system. We propose AI-powered triage systems as a solution. These systems can objectively analyze patient data, ensuring faster and more efficient care. Let me introduce the team behind this innovative approach, nicknamed the Musketeers by Evgeny Shvarov. The team consists of José Roberto Pereira Jr., Henrique Diaz, and Henry Hammond Pereira. Here's how our solution works in practice. First, a patient sends a text message to our Telegram bot. The InterSystems Iris interoperability platform receives this message, and the router identifies it as text. It then forwards the message to Medicopilot, which performs a vector search in a database of patient-doctor dialogues. Based on these dialogues, Medicopilot generates a response with guidance and a possible diagnosis, which is then sent back to the patient via Telegram. In another scenario, a patient sends a voice message reporting symptoms to the Telegram bot. InterSystems Iris interoperability receives the message and identifies it as an audio file. The voice message ID is sent to Telegram, which returns the audio in BASIS 64 format. This file is then processed by OpenAI, which transcribes the audio into text. The transcription is sent to Medicopilot for a vector search in the patient-doctor dialogue database. Medicopilot then responds to the patient via Telegram with guidance and a possible diagnosis. Now it's demo time. Let's take a look behind the scenes.
Hello, I've been feeling really swollen lately, especially in my hands and feet. Also, I've been having blurry vision and headaches. Can you help me?
Yeah, it's maybe I comment what's going on. Actually, colleagues, they're exposing interoperability package of InterSystems that they are using with to build this.
By leveraging AI
Pilot.
in triage, we can improve efficiency, reduce costs, and ensure patients receive timely care regardless of the attending physician's experience level.
Yes, I didn't ask, so I hope you heard everything, and I think you heard also. We all were hearing to a robot, but I believe with a female voice. But I can comment that I really like this application. So because of this template, I was able to build my own Telegram bot using this template, which answered, to which I was able to talk to, and it answered me some like explanations of my conditions based on the information that that the system were taught and with the Rex scenario. So I think very nice work. Guys, if you will watch this again as a recording, great job. Thank you.
Indeed. Thank you very much. Thanks for participating. All right, last but not least, the first place winners, DG Appeal AI app. I see them online here now. Please take it away, ladies.
Hello, everyone.
Hello.
Hello, everybody. We are Banksia Global team, and we would like to tell you about our application that won the contest. Banksia Global is an international boutique consulting company providing professional services for intersystems technologies. At Banksia Global, we deliver full-cycle software development services to mid-sized companies and large enterprises. Our team members have decades of experience building innovative solutions on intersystems platforms. As for BG Appeal AI, it was developed as an example of using intersystems technologies and modern AI technologies. The main task that our app solves is writing an appeal of an insurance company's refusal to reimburse medical expenses. As usual, our application consists of two parts, backend and frontend. The frontend was developed using Angular. API was developed with intersystems. For vector search and content generation, we have used LangChain and OpenAI. So how does our application work? First, the user uploads the insurance contract and rejection letter into the systems. These documents are split into parts and converted into vectors for easier processing later. Then the system BG Appeal AI generates a prompt and makes a request to OpenAI. Is an appeal possible? If yes, the system receives a draft appeal later and returns it to the user.
Hello, today I would like to show the server side of our application. The core of backend development is built on interoperability production, which uses vector search and generative artificial intelligence. There are two main logical components based on BPL process. The first components are responsible for document vectorization, such as insurance contract. It starts with the document in service as the data entry point. Next, data is passed to the conversation to vector process, where it's first pull out text using getText process. After that, it saves the document and its vector from using save development document and save vector. The second part for vector search begins by getting data through appeal in service. Then it processes in BPL process vector search using tools like OpenAI out to talk with OpenAI API. It's use safe appeal to store data generated by artificial intelligence. Let's take a look at each of existing process. First process, it's getText. It's a process that takes data from a file and turn it into a stream. This stream is used for additional text processing and analyze. It can handle two common types of file extensions, docs and PDF, which are the most common ones used for documents. Next process, it's conversation to vector. It's a way to turn text from a file into vectors. Here's show how it works. We take two words out of the file and break them into smaller chunks using link chain. Then each chunk gets turned into a vector. Finally, we put all these vectors together in a list so we can easily search for them latest using vector search. And next step, we use vector search process. We begin by getting a vector from text of rejection letter. Then we search for similar parts in all our documents using vectors. If we find something, we check it with OpenAI to see if we can appeal the rejection letter. If it's possible, we also write an appeal letter using OpenAI helps. That's a simple overview of the backend part works.
Mm-hmm.
Hello, my name is Kate. I also work for Banksy Global, and I'd like to show you our easy application. First, we need to define an insurance company. You can choose one of existing, or you can create a new one. Second, we should add a package for this company. We also can choose or create a new one. Also, we should upload all the available data about insurance products, such as insurance contracts, limits, exclusions, and all documents that we have about this package. After that first steps, users should input the letters with specific details about the insurance procedures, about reason for denial, and information about patients. The system uses vector search to quickly sift through data uploaded on the previous step, and finally, using generative AI, the system drafts a customized appeal letter. Great job. And of course, we'd like to add that it was really interesting contest, and it's a big honor to be part of it. And compete with such strong guys, such professionals, and we greatly appreciate it. Thank you, InterSystems, and thanks to everyone.
Thank you. Really cool. Any questions for the BG Appeal AI team?
Great app. Thanks so much. Yeah, very complete and nice. One thing I saw, and I didn't get to really dig in, but you have the wait, kind of block in your business process diagram after, calling these long, API calls to OpenAI. Is that a limitation of like our business process setup where it doesn't handle waiting like automatically, or is there some other asynchronous way that you guys would like to do it that we don't support?
Okay. In this part, we use it because call to OpenAI use asynchronous calls.
Okay. Okay, I see. So I'm just wondering if there's a better way, if we should have a better tool, and maybe someone else wants to answer that, because I'm not very familiar. I don't know the interoperability infrastructure very well. So it's kind of just general question. But thank you.
Thank you very much.
In fact, community did a really great job on providing components for interacting with OpenAI. We have at least 2, I believe, packages that are available on OpenExchange that tackle this. So I'm not sure if what colleagues from BG appeal they used in this case. But yeah, so I mean, this is not something we need enhancement in InterSystems platform. This is what actually InterSystems provides as a platform that allows to build components to interact through interoperability platform. Yeah. So I think this is well done. Yeah. So thank you.
Very cool. Thank you very much. Congratulations again to all of the winners. We very much appreciate it. Thanks to everyone that participated in this contest. Please do check out our next contest. It is not yet announced, but if you join the InterSystems developer community, that's where we'll post the next announcement for the next contest. Thank you all very much for joining this webinar. See you soon.